Hi, grade 12. Welcome to Tutorbox Live in conjunction with COVID-19 kick-off courses. Right, so guys, before we start, I'm Lisa, the math tutor for you guys that are joining me today for the first time. Welcome, welcome, welcome. Right, so before we start grade 12, I just wanted to tell you that I know there's a lot going on with the whole COVID-19 crisis and all that, right? But I think the most important thing for you guys to do is to just stay prepared. We don't know what's going to happen, right? And you guys don't want to find yourself in a situation where you're like, oh my God, it's end of year, and then they tell you, boom, you still have exams. So just stay prepared, be up to date, revise as much as you can, right? And just use these free lessons, right? We're here to help you, and we care about you and the success. Okay, we want you guys to succeed. Okay, guys, so there's no waste time. Let's start with today's work.
Hi grade 12s, welcome to our second session. So today we're going to be looking at geometric sequences and series part 1. Okay, so what is a geometric sequence? A geometric sequence is a sequence of numbers in which each new term, except for the first term, is calculated by multiplying the previous term by a constant value called the constant ratio. Okay, so in the geometric sequence, we can determine the constant ratio R from, we take the second term divided by the first term, which is equal to the third term divided by the second term, which is equal to R. So more generally, we have Tn divided by Tn minus 1 is equal to R. Okay, so guys, note the difference between an arithmetic and a geometric. Arithmetic, for us to get our common difference, that's what it was called that time, you take, let's say, the next term minus the previous term. But then for geometric sequence, right, to get your constant ratio, this side, it's a ratio, guys. It's not a difference, it's a ratio. You take your next term divided by your previous term. So here it's T2 divided by T1, T3 divided by T2, T4 divided by T3, and so on. Okay. And then let's look at these examples. It says first find the constant ratio R and then get the next three terms. So we have 5, we have 10, we have 20, and so on. Okay, so we want the constant ratio. To get the constant ratio, we're going to take, let's start with this guy, because this is T1, T2, T3, right? So let's first start here. We have T2 divided by T1. We get 2 there. And then if I also want to check whether my constant ratio applies to all the terms, I can just, in this case, I can take 20 divided by 10 and I get 2, right? So which is the same R that I got previously. Okay, so then now to get the next terms, I'm going to multiply, because I have term 1, term 2, term 3. So I'm going to multiply this 20 times the 2, I get 40. That'll be my fourth term. To get my fifth term, I multiply the 40 times 2, I get 80. 80 times 2, I get 160, and so on. Okay, and then let's look at example 4 there. We have P, 3p squared, 9p cubed, and so on. Okay, so it's the same thing. To get the constant ratio, we take the T2 there divided by the T1, which is 3p squared divided by p, or you can take T3 divided by T2, right? You should also get 3p, right? And then now to get the next terms, you basically multiply the previous term times that constant ratio there. Okay, so you should get 27p to the 4, 81p to the 5, and 243p to the 6. Right. So therefore, the general formula for a geometric sequence is Tn is equal to a r raised to the power of n minus 1, where a is the first term in the sequence. A there is the first term in the sequence. R is the constant ratio. R there is our constant ratio. Okay, and then we have test for a geometric sequence. So in case they ask you a question and be like, okay, determine whether it's an arithmetic, a quadratic, or a geometric, right? So to test for a geometric sequence, check if the ratio between any two consecutive terms is constant, right? So you have to check this guy here. If T2 divided by T1 is equal to T3 divided by T2 is equal to Tn divided by Tn minus 1, which is equal to R. Okay, so if this condition does not hold, then the sequence is not a geometric sequence, guys. Right? And then I did this example to just like put all the questions that I could ask you in like one nice example there. Right, so it says, so let's just recap on this. The general formula, Tn is equal to AR, n minus 1, and R is our constant ratio, and A is our first term, right? So for example, let's say they give you 2, 3, 4,5, and 6,25, right? So 2 is the first term, 3 is the second term, 4,5 is the third term, 6,25 is the fourth term, right? So to get my constant ratio, I'm going to take, let's first take T2 divided by T1, right? So if I take T2, which is 3 divided by 2, and I can also take 6,25 divided by 4,5, right? I also get 3 over 2 and 3 over 2. Okay, so we've done the test, so it checks as a geometric sequence, right? And then now, the question is saying find the formula. So let's say they don't give you the general formula and then you have to find it, right? So it's the same numbers, 2, 3, 4,5, and 6,25. So you need to find the general term or the general formula for these sequence right here. Right, so you know that for your general formula, you need an A, obviously, you need what R is, right? And then n minus 1, you leave it as n minus 1 because that's the general term. The general term, guys, is always in terms of that n, okay? It's always just n only, okay? So we have 2, 3, 4,5, and 6,25. So we already found that our constant ratio was 3 over 2, right? And A there, which is 2, that's T1. That's our first term. So A is 2, R is 3 over 2. So therefore, Tn will be equal to 2 times 3 over 2, all this raised to the power of n minus 1. Okay. And then the second one says finding a value or a term. So in case they ask you, find the fourth term, find the fifth term, the 20th term, and so on. Okay, so this is what you do, right? So the 15th term in this case will be equal to 2 times 3 over 2. So whether it's n, right? Because remember, Tn is equal to AR to the power n minus 1, right? So now you want the 15th term. So whether it's n, you're going to replace with your 15, right? So this becomes the 15th term is equal to 2 times 3 over 2 raised to the power of 15 minus 1, and you should get 583,86, right? And then last one, they can ask you to maybe find a position, right? So for example, right, let's say they give you this general term here, or the general formula. Tn will be equal to 4 times 3 raised to the power of n minus 1. And then the question asks, which term is equal to 8,748? Right, so which term is equal to this? Right, so what you're going to do is for your Tn, you're going to replace it with 8,748. This will be equal to 4 times 3 to the power of n minus 1, right? And then if I divide by 4 the side, and I divide by 4 the side, I should get 2,187 is equal to 3 raised to the power of n minus 1. Right. So guys, you want to solve this equation. Right. You want to solve this equation. So what you have to do is you have to change this number here so that you get the same base, this side and that side, right? So the easiest thing that you can do, in case you don't know how to change this, you can just use prime factorization. But if you don't know, you can just use your calculator. So this is what you do. You put the number. So in this case, you put 2,187, okay? And then you press equals, right? So that number should display on your screen, right? And then after that, you press shift, right? And then you press this button here that has fact written there, okay? So it's actually going to work this out for you. It will give you an answer in terms of prime factorization there, okay, in your calculator, right? So now that they have the same base, you can just equate the exponents. So your answer will be 7 is equal to n minus 1. And then if you take this minus 1 to the other side, it becomes a plus 1. So that'll be n is equal to 8, right? So that means the 8th term is equal to 8,748. So geometric mean, the geometric mean between two numbers is the value that forms a geometric sequence together with the two numbers, right? So for example, the geometric mean between 5 and 20 is the number that has to be inserted between 5 and 20 to form the geometric sequence 5, that number, and 20. Right, so to get our x, right, just use the constant ratio, right? So determine first what the constant ratio is, right? So to do this, you would take the second term divided by the first term. This would be equal to the third term divided by the second term, right? So you agree with me that this x over 5 would give us the constant ratio, and this 20 over x will also give us the same constant ratio, right? So to get x, why don't we just equate those two, right? So let's see what will happen. So we can cross multiply with x squared is equal to 20 times 5. So x squared will be equal to 100. So therefore, x is plus or minus 10x, right? So guys, please note that this is the x that we're looking for, right? This x here is not the constant ratio. No, it's the x that we're looking for. The constant ratio is this part, the x over 5 and the 20 over x. So because I found that x was either plus or minus 10, if I take maybe the positive 10, if I put it here, 10 over 5, so my constant ratio would be 2, okay? And then now, this is very important. Remember to include both the positive and negative square root, because if you take the square root of a certain number, you get a plus or a minus, right? So the geometric mean generates two possible geometric sequences. So you can either have 5, 10, 20, or 5 minus 10, 20, and so on, right? So in general, the geometric mean between two numbers, the geometric mean x, they're between two numbers a and b, they form a geometric sequence, right? So if you want to get your x, what your x is, you want to determine what x is, all you have to do is take the constant ratio, use that term, that is the x, the unknown, and then divide it by a term that's already known, that's given to you, right? And then you equate 2, and then you take another part, like in this case, you take a b, you divide it by that unknown, and then you solve it to get what x is, okay? Right, so now time for some examples. So this example is quite long, guys, but just please follow through as I explain it, right? So it says, consider the following terms with k minus 4, right? That's our first term. K plus 1, that's our second term. M and 5k. Third term, fourth term. So it says the first three terms, right, they form an arithmetic sequence, and the last three terms form a geometric sequence. So determine the values of k and m if both are positive integers, right? Whew, that's a lot. Okay, so it says the first three terms, they form an arithmetic sequence, right? So this term, and that term, they form an arithmetic sequence. And then the last three terms form a geometric sequence. Okay, so let's just break it down. Let's first look at this part, the arithmetic one. So k minus 4, k plus 1, and m, they form an arithmetic sequence, okay? So because they form an arithmetic sequence, that means there has to be a common difference. So if I get my common difference, I take k plus 1 minus k minus 4 there, right? So this will become k plus 1. This minus is multiplying that plus k there, so that will be minus k. This minus times the minus 4, that will be plus 4. And then I simplify, I get k minus k 0, plus 1 plus 4, I get 5, right? And then I double check with another common difference, right? So in this case, I'm going to get d is equal to t3 minus t2, right? And then now, because remember, you have unknowns here, okay? So you're actually not going to get a 5 because you have these unknowns here, right? So let's just look at it. So if t3 minus t2, t3 is m minus t2 is k plus 1. There's k plus 1. So this will be equal to m minus k, and then minus times the plus, that'll be minus 1, right? So what you know is, because it's an arithmetic sequence, this d here should be equal to this d here, right? So therefore, 5 will be equal to m minus k minus 1, right? So I have my first equation as, I can rewrite it as m is equal to k plus 6, okay? Because here they say determine the values of k and m if both are positive integers, okay? So you could have even put k as the subject of the formula, but then in this case, let's just use m, right? And then it also said, so that was for the first part, the arithmetic sequence part. The second part says the last three terms form a geometric sequence. Okay, so let's see what we can do with that. So the last three terms of k plus 1, m, and 5k, right? So geometric sequence, constant ratio, okay? So I'm going to determine my constant ratio. So I'm going to take t2 divided by t1. I get m divided by k plus 1, and then if I take T3 divided by T2, I get 5k divided by m. If I equate these together, because remember they're equal, I get m over k plus 1 is equal to 5k over m, right? And then I can cross multiply them. I have m squared, right? Guys, you can only cross multiply if you have like one term here equal to another term. That's when you can only do that. But if you have like maybe 3 terms, 4 terms, you can't do that. Okay, so with m times m is m squared is equal to 5k times k plus 1. Okay, so m squared is equal to 5k squared plus the 5k. I just expanded this part, right? Okay, so remember this side, we got that m was k plus 6. Now we're getting that m squared is 5k plus 5. 5k squared plus 5k, right? And then now we're going to substitute that equation 1 that we got, that m was k plus 6. Okay, so where there's m, I'm going to put k plus 6, so that'll be k plus 6 squared is equal to 5k squared plus 5k, right? And then now I'm going to expand this guy here. So I get k squared plus 12k plus 36. Guys, if you're not sure how I got from this step to this step, please just revise your grade 10 algebra. It's very easy, okay? So you just expand this and then you use your FOIL, right? So you should get k squared plus 12k plus 36 is equal to 5k squared plus 5k, right? And then this now will be equal to, if I take this k, I put it on the other side, I get 5k squared minus k squared, I get 4k squared. And then I have 12k, and then here I have plus 5k. If I take this plus 12k to the other side, I get 5k minus 12k, I get minus 7k. And then this 36, it will also move to the other side, becomes minus 36, and then I get this equal to 0, right? Now, then I factorize, right? I should get 4k plus 9 and k minus 4. Guys, still, if you don't remember how we did this, please just revise your grade 10 algebra. So this will be equal to 0. So therefore, k will be equal to minus 9 over 4, or k is equal to 4. Okay, right. But then remember, they gave us a note. They say that determine the values of k and m if both are positive integers. So they have to be positive integers. Okay, right. So first I got a k there, that's minus 9 over 4, and another k, which is 4. So obviously I'm going to take the k is equal to 4 because that's the one that is a positive integer. This one is negative, and I don't think that's an integer either. Okay. So therefore, k is 4. And then, because now I have my k, I can now calculate what my m is. Remember, we said m was k plus 6, and we just got that k is 4. So m will be 4 plus 6, and you get 10. Right. So therefore, k is 4, and m is 10. Right. Okay. So then now you can just substitute and give them the right term. So if k is 4, m is 10, the first term will be 0, the second term will be 5, the third term will be 10, and the fourth term will be 20. Right, so guys, next up is series. Guys, not this type of series, not TV series, this series, the math series. Okay, so it is often important and valuable to determine the sum of the terms of an arithmetic or geometric sequence. So the sum of any sequence of numbers is called a series. So the sum, this is NB guys, the sum of any sequence of numbers is called a series. So a series, we're basically adding the sequence of numbers. That's what we're doing. Okay, so there are two types. There's a finite series and an infinite series. So first, let's just look at finite. So we use the symbol Sn for the sum of the first n terms of a sequence, right? So with T1 plus T2, T3, T4. Okay, so our sequence is T1, T2, T3, T4. So Sn, which is the sum, will be equal to T1 plus T2 plus T3 plus everything there plus Tn. Okay, so series, we're summing, guys. Okay, so if we sum only a finite number of terms, we get a finite series. So for example, consider the following sequence of numbers. So we have 1, 4, 9, 16, 25, 36, 49, right? And then they say maybe calculate the sum of the first four terms. The sum of the first four terms. 1 plus 4 plus 9 plus 16. And you should get 30. So you write it as S4 because they're saying the sum of the first four terms is equal to that, which is equal to 30. So this is an example of a finite series since we're only summing four terms. It's finite, right? You know how many terms. It's like 5 terms, 7 terms, 8 terms. And then infinite now. Okay guys, so however, for infinite series, if we sum infinitely many terms of a sequence, we get an infinite series. So infinity, it means it goes on and on and on. It just goes on. It just keeps going on. Okay, so for instance, we're summing this to infinity. We're going to sum T1, T2, T3, all the way to, we don't know where it's going to stop. All right, so we'll cover this in our next session. So for now, I just want us to do the finite series one, right? And then we also need to know our sigma notation, right? So sigma notation is that guy there. Okay, so sigma notation is a very useful and compact notation for writing the sum of a given number of terms of a sequence. So a sum may be written out using the summation symbol, that's sigma, right? Which is the capital letter S in the Greek alphabet. It indicates that you must sum the expression to the right of the summation symbol, right? So guys, it's this guy. That guy is called sigma there. Yeah. So for example, right, so then let's say you have that sign, right? And then we have n is equal to 1, and we have 5 there, and then we have 2n. Okay. So basically what they're asking you to do is they're asking you to sum 2n from the moment that n is 1 up until n is equal to 5. Okay, so this is why they said for the first one, you just substitute your 1 there, you get 2. For the second one, when n is 2, you get 2 times 2, which is 4. When n is 3, you get 2 times 3, which is 6. When n is 4, you get 2 times 4, which is 8. And then when n is 5, you get 2 times 5, which is 10. You see, so we sum from n is 1 all the way to 5. Right, so you get your answer to be 30. Okay, so in general, if you're summing Ti from I is equal to m all the way to n, so this will be equal to Tm plus 1 plus all the way to plus n minus 1 plus Tn. Okay, this n minus 1, it's the number before n. Okay, so that's why we're saying plus n minus 1 and then plus Tn, the last one. Okay, right, so I is called the index of the sum. Let me just go back so you guys can see. So I here, that's the index. Okay. M is the lower bound. Let me actually use this one here. Okay. So I is the index of the sum. There is our I there. Okay. M is the lower bound or start index shown below the summation symbol. So there's our M. N is the upper bound. There is our N there. Okay. So or the end index shown above the summation symbol. Ti is a term of a sequence, okay? And then the number of terms in the series, this will be equal to the end index, which is that n, minus the start index. My start index is my m, plus 1. Okay, so that will give me the number of terms in the series. Okay, and then the index I increases from m to n by steps of 1. So note that this is also sometimes written as this. Okay, guys. Right. And then when we write out all the terms in a sum, it is referred to as the expanded form. So when you write them all out, right, like 1 plus 2 plus whatever, it's referred to as the expanded form. So if we're summing from I is 1, which implies summing from the first term in a sequence, right, then we can use either Sn or the sigma notation. Okay. Right. So let's just quickly look at this example. So we have, this example falls under sigma notation, guys. So it says expand the sequence and find the value of the series. Okay. So here they're asking you to sum 2 to the power of n from the time that n is 1 all the way to 6. Okay. So the first step, expand the formula and write down the first 6 terms of the sequence. Right. So you're starting with n is 1. Right. So first, you're going to have 2 to the power of 1, okay? And then you go to n is 2, plus, because it's a sum here, it's a summation, okay? Plus 2 to the power of 2, plus, you go to n is 3, 2 to the 3, plus 2 to the 4, plus to the 5, all the way to 2 to the 6, okay? And then you get 2 plus 4 plus 8 plus 16 plus 32 plus 64, okay? So this is a geometric sequence, 2, 4, 8, 16, 32, 64, with a constant ratio of 2. So you can just check this, guys. 4 divided by 2 is 2. 8 divided by 4 is 2. Okay, so our constant ratio is 2. Okay. And then step 2, because it said expand the sequence and find the value of the series. Okay. So step 2, determine the sum of the first 6 terms. So you're just going to add these. Okay. You should get 126. So you notice, guys, we say the sum of the first 6 terms is equal to that, which is equal to 126. Right. And then now let's look at this one. So this one is the opposite, right? So now we have to write the following series in sigma notation. Right. So we have 31 plus 24 plus 17 plus 10 plus 3. Right. So step 1, consider the series and determine if it is an arithmetic or a geometric series. Okay, so first let's test whether it's an arithmetic, right? And is there a common difference? So first let's just ignore those pluses there. Let's take it as just the sequence. So 31, 24, 17, 10, and 3. Right, so now let's check whether it's an arithmetic series. Let's check for a common difference. So our first term is 31, second term is 24, third term is 17, fourth term is 10, fifth term is 3. Right, so if we check for a common difference, T2 minus T1, that would be 24 minus 31, we get minus 7. Then if we check again whether that common difference applies to all the other ones, we have T3 minus T2 is equal to 17 minus 24, and we get minus 7. Oh, there we go. Yay! It's an arithmetic sequence. Okay, so therefore the common difference is minus 7. So hence, it's an arithmetic series, right? So now we need to get the general formula of the series, right? So we have, for an arithmetic, Tn is equal to a plus n minus 1 bracket d, right? This will be equal to our first term is 31, remember? Our first term is 31 plus n minus 1 times minus d there. If you simplify, you get minus 7n plus 38, okay? So be careful, brackets must be used when substituting d is equal to minus 7 to the general term. Otherwise, the equation would be my 31, Tn is equal to 31 plus n minus 1 minus 7. Okay, so guys, you need to be careful. This minus here is actually going to multiply everything in there. It's not a minus 7, as in it's another term like minus 7 standing by itself. No, it's not like that. Okay, so this would be incorrect. Right, and then step 3, because remember our question says write the following series in sigma notation. Right, so step 3, you determine the sum of the series and write in sigma notation. Right, so let's first add these. 31 plus 24 plus 17 plus 10 plus 3. This will be equal to 83. Okay, so this part here, guys, it always has to be your formula or your general term. That's the part that you put here for your summation. Right, so we're summing from n is 1. We're summing from n is 1 all the way to 5. And then we've got our general term to be minus 7n plus 38. Okay, so this will be equal to 85. Okay, so guys, because the question just asked you to write in sigma notation, don't go back and start expanding this. They just asked you to write it in sigma notation. Okay, so this is how you write it. So you put your general term, your general formula there, and then you sum it from the first term to the fifth term, in this case, because there are 5 terms, 1, 2, 3, 4, 5. So you're ending with 5 there, starting with n is 1, and then you put your general term that you worked out here, and then that will be equal to 85. Okay, so these are the rules for sigma notation. Given two sequences AI and BI, right? So if you sum I is 1 all the way to n, and you're summing AI plus BI, this will be equal to the sum of AI, right, plus the sum of BI from I is 1 all the way to n. Okay, and then 2, so you need to know this, guys, and then 2 for any constant that is not dependent on the index I. So if this C is not dependent on the index I, so all you do is you just factor it out there. Okay, so you put it outside because it's not dependent on I. So here you always want something that's dependent on I. Okay, and then 3, be accurate with the use of brackets, right? Example, right? So we have the sum n is 1 all the way to 3, and we have 2n plus 1 there. Okay, so first you start with your 1. 2 times 1 plus 1, that will be 3, plus 5 plus 7, and then you get 15, right? And then now you see how brackets are very essential, guys. You need to like take note of where the bracket is. So here the bracket, that 2n plus 1 is inside the bracket, all of it. Okay, so that means that the n here, this n will change this whole thing here, right? And then if you come to this example, we have that 2n is in brackets by itself, and then outside you plus in 1. Okay, so first what you're going to do is, because this is a constant, it's not dependent on any n, guys. It's not dependent on any n at all, right? So first you're going to sum these parts, the 2n part. Okay, so that will be n is 1. And when n is 1, this will be 2. There's my 2 there. When n is 2, this will be 4. There's my 4. When n is 3, this will be 6. Okay, so now I sum this 4 plus 2 plus 6. And then after I get the answer to that, I add my 1. And then I get 13. Right. So note the series in the second example has the general term Tn is equal to 2n, and the plus 1 is added to the sum of the 3 terms. It is very important in sigma notation to use brackets correctly. Guys, please make sure you use your brackets correctly. Okay, so right, and then the fourth one, the rules, this I've explained before, right? So the values of i's, they start at m. There's m. So guys, m is not always 1. Hey, it's not always 1, because I've been using examples with 1, but it's not always 1. It can start with 2, it can start with 3 or 4 or 1 million or 1,000, whatever. So the values of I start at m. M is not always 1. Increase in steps of 1, and they end at n there. Right.
We're doing serious research, which requires complete and utter focus.
All right, let's buckle down and work. Sheldon,
What?
I need an aspirin.
Top desk drawer. Thank you. All right? Yes, good.
All right, guys, so now it's time for you guys to do some quick math. So I'll give you guys 2 minutes to look at these and just scribble down how you think you'd answer this, and then yeah. Alright guys, so let's just look at it quickly. If you have questions after we look at the answer, you can just join me in the Q&A and then you ask me. Okay. So number 4 says write the following sigma notation: 1/9 plus a third plus 1 plus 3. Number 6 says write the sum of the first 1000 natural odd numbers in sigma. Okay, number 6 might be a bit tricky, but let's just look at it. Okay, so number 4 says write the following in sigma notation: 1/9 plus 1/3 plus 1 plus 3. So guys, this example is similar to the one that we just did, because it's the opposite, right? We're writing in sigma notation. Okay, so first we need to check what we're working with. Is it arithmetic or geometric? So in this case, it's a geometric series, and A is 1/9, and then R, which is our constant ratio, is 3. Okay, so if you don't remember how we do constant ratio, you take this next term. In this case, it's T2, 1/3 divided by 1/9. Okay, and then you should get 3. And then if you take this 1 divided by a third, you should also get 3, or 3 divided by that 1, you should get 3. Okay, so the general formula then will be Tn is equal to ARn minus 1. That's our general formula. Tn is equal to ARn minus 1. Okay, so now I want to substitute the values that we got for A and for R, right? Because remember, this Tn, that's the one that we put after our summation. The general formula or the general term is the one that we put after our summation, right? So Tn will be equal to ARn minus 1. This will be equal to our first term, which is 1/9. The R there is 3 raised to the power of n minus 1, right? So this will be equal to 1/9. I can change this. It will be 3 to the power of minus 2. Okay, so guys, if you don't remember how to do this, you can just plug it in your calculator. It should give you that answer. Okay, and then this will be 3 to the power of n minus 1 there. Okay, so now I have the same base. They are multiplying, so I'm going to add my exponents. So that'll be minus 2 plus n minus 1. Okay, so that'll be n minus 3. So basically, this is my general formula. Right, so then now I want to write it in sigma notation. Yes. Sigma notation. Okay, so we have 3n minus 3 to the power of n minus 3 there. So n starting from the first term all the way to, let's just check how many terms we have. 1, 2, 3, 4. Okay, so there we go. N is 1 all the way to 4, and we're summing this guy there. Okay. And then let's look at 6. It says write the sum of the first 1000 natural odd numbers in sigma notation. So the sum of the first 1000 natural odd numbers, guys. Natural numbers, remember, 1, 2, 3, 4, counting numbers. Okay. Odd numbers, guys, you know this from grade 2. So you should have gotten 1 plus 3 plus 5 plus 7 and so on. Okay, so you notice that this, if I get the difference here, this one is an easy one. You can actually notice that it's an arithmetic. Okay, the difference here is 2, the difference here is 2, the difference there is 2. Okay, so it's an arithmetic series with A equal to 1. So our first term is 1 because natural numbers are starting at 1, and then our common difference is 2 there. Okay, so now our general formula is Tn is equal to A plus A minus 1 bracket D. And then now I substitute. A is 1. There's 1. A is 1 there. D is 2. D is 2 there. Okay. So then I just simplify and I get 2n minus 1. Right. And then now it's easy. All I do is after my sigma, I put my general term or my general formula. And then I'm summing from the first term. N is 1 all the way to 1000. Right. Or you can sum from n is 0 all the way to 999. Okay, so guys, let's just check this one here. Okay, so you have the general term to be 2n minus 1, right? And then this one here is 2n plus 1. So if I substitute here my 0, I get 0 here, then I have plus 1. So still I'll get 1 for the first term. Okay, so but then guys, if this is confusing you, you can just leave it here. Just leave it there. The final answer will be this, which is also correct because your Tn, actually you got it as 2n minus 1. Okay, so this is another way of thinking about it here. Okay, right. And then we have finite arithmetic series, right? So guys, let's just this is very easy. We're just going to recap on that. We did this in grade 10. So in arithmetic sequence, the sequence of numbers, we have a common difference there. This is our general formula. Tn is a plus n minus 1 bracket d. Okay, so let's just dive into this part here. So when we sum a finite number of terms in an arithmetic sequence, we get a finite arithmetic series. So guys, we need to know the proofs that are going to follow after this. Okay, so before we do those proofs, let's just look at this part first. Okay, so the sum of the first 100 integers. So a simple arithmetic sequence is when a is 1 and d is 1, which is the sequence of positive integers, right? So Tn will be a plus n minus 1 bracket d. This will be equal to 1 plus n minus 1 times 1. This will be equal to n, right? Because it's a simple arithmetic, a is 1 and d is 1. Okay, so basically you're counting 1, 2, 3, 4, 5, all the way to whatever. But then in this case, we want to go to 100, right? So if we wish to sum this sequence from n is 1 to any positive integer, for example, 100, we could write the sum of n from n is 1 all the way to 100 as 1 plus 2 plus 3 all the way to plus 100. Do you guys notice that this is a finite? Okay, it's a finite series, right? So this gives the answer to the sum of the first 100 positive integers, right? Okay, so guys, for the proof that's coming, so you need to note the following. So first, you write the numbers in ascending order. You write the numbers. Second step, you write the numbers in descending order. Third step, you add the corresponding pairs of terms together. And then fourth step, you simplify the equation by making Sn the subject of the equation. Okay, so let's say they give you maybe, I don't know, they give you like some numbers, right? And then they say get the sum of the first 1000 numbers. So you can't obviously take your calculator and just put all the 1000. You won't have time for that in the exam. Okay, so this is why this formula comes to our rescue. Okay, so let's just look at it. So still we're using this example here. Okay, the sum of the first 100 integers. Okay, so first it says write the numbers in ascending order. So first the sum of the first 100, that'll be 1 plus 2 plus 3 plus 4 plus 5 all the way to plus 98 plus 99 plus 100. Okay, step 2, write the numbers in descending order. Now we want to write in descending order. So you still take the same thing, the sum of the first 100, right? This will be equal to, you write it in descending order now. Descending order, start with the 100 plus the 99 plus the 98 all the way to plus 3 plus 2 and plus 1. Okay, and then add the corresponding pairs of terms together. Okay, so first let's add this part. So if S100 plus S100, so this will be 2S100. Okay guys, this will be 2S100. So you can actually think of this as maybe a variable. Let's say this was x. X plus x, that will be 2x. Okay, so that's why it's S100 plus S100, that will be 2S100. So this will be equal to, right? So add the corresponding pairs of terms together, right? So you want to add the pairs together. 100 plus 1 is 101, 99 plus 2, 101, and so on. Okay, so you notice that everywhere you're just going to get 101, right? So now if I simplify it further, I get 2S100 is equal to 101 times 100, because I actually have 100 101s. Yes, I got it right. Yes, 100 101s. Yes. Right, so you're multiplying 101 by 100, right? Because it's 100 of them, right? Okay, so now this will be equal to 10,100. So you have 2S100 is equal to 10,100. And then now we want to get what S100 is, and we get 10,100 divided by 2, and we get our answer to be 5,050, right? All right, guys, so now we also need to know the general formula for a finite arithmetic series. So if we sum an arithmetic sequence, it takes a long time to work it out term by term, right? We therefore derive the general formula for evaluating a finite arithmetic series. We start with the general formula for an arithmetic sequence of n terms and sum it from the first term A to the last term in the sequence. Okay, so guys, remember those steps that I wrote down here for you, okay? right? So we want to sum. Okay, so first we'll start with this guy here. So let's just take it from here. We'll start with the general formula for an arithmetic sequence of n terms and sum it from the first term A to the last term in the sequence L. So now we're summing it all the way to the last term. Okay, right. So we have Sn. This will be equal to, the first term will be A. It's an arithmetic sequence, hey? The first term would be A, right? The second term will be A plus D because it's an arithmetic sequence. So it's increasing. Each term increased by D. So the second term will be A plus D. The third term will be A plus 2D, okay? And so on, right? All the way to L minus 2D, last term minus 2D, plus L minus D, and plus the last term. Okay, so now the second step is to write in descending order. So I just rewrite this, guys. Sn will be equal to descending order. I start this side now. L plus L minus D, because guys, this is the last term. This is the last term, yeah? So this will be the last term minus the difference to get the second from the last term. Okay, and then the third from the last term. The third from the last term, that'll be L minus 2D. Okay, right, in case some of you are like confused where that's coming from, right? And then this side will be plus whatever, A plus 2D plus A plus D plus A. So basically I just wrote this. This is an ascending, this is not descending. And then the third part, you need to add the pairs together, add the corresponding pairs of terms together. So Sn plus Sn, you get 2Sn. This will be equal to A plus L. This will be equal to A. This part here is A plus L, guys. Okay. And then this part here would also be A plus L, because I have A plus D, right, plus the L minus D. Okay, so the D's will cancel out there. So I'll be left with A plus L. Everywhere throughout I get A plus L. Right. So now this will be 2 times Sn is equal to, because I'm summing all the way to n, yeah? So then I have A plus L, and I have n of these, okay? So this would not be n times A plus L, right? So this will be equal to Sn is equal to n over 2A plus L. So in case you guys maybe get here and you get stuck and you don't know what's going on, right? You don't know what to multiply this A plus L with, right? So you can just look here, you have that n there. So basically that's the number that you're going to multiply with. Okay, so then Sn will be equal to n divided by 2, because I'm going to divide by 2 here and be left with Sn, n divided by 2 times A plus L, right? And then this general formula is useful if the last term in the sequence is known. Okay, so it's very useful if the last term is known, right? So we substitute L is equal to A plus n minus 1 bracket D into the above formula and simplify. So in case you don't know the last term, right? So all you have to do, because now you don't have the last term, so that means you have the nth term, right? So all you have to do is just substitute the L with the A plus n minus 1 bracket D into the above formula, and then you just simplify it. Okay, then you should get Sn is equal to n over 2 times 2A plus n minus 1 bracket D. Right, so the general formula for determining the sum of an arithmetic series is given by that guy there. Okay, so that guy is even saying total. So it's given by that guy. So this one is when you don't know the last term, yeah? And then this one is when you do know the last term, right? Right, so for example, we can calculate the sum S20 for the arithmetic sequence Tn is equal to 3 plus 7n minus 1 by summing all the individual terms. Okay, so you can, this one at least is 20, so it's not that much of a nightmare, but it's still a nightmare. I mean, look at this, who has time to do that? But anyways, let's just look at it and see whether we get the same answer using the long method and the same answer using the formula. Okay, so if, for example, we can calculate the sum S20 for the arithmetic sequence that by summing all the individual terms. So S20, we're summing from n is 1 all the way to 20, 3 plus 7, n minus 1, right? So this will be equal to, you just add those, you get 1,390, right? Or we could use the general formula for determining an arithmetic sequence by substituting A is 3, D is 7, and N is 20. Okay, so you would also do that and then you get 1,390. So this example demonstrates how useful the general formula for determining an arithmetic sequence is, especially when the series has a large number of terms. Alright guys, so that's the end of our session. Thank you for joining me. Do join me next time. Don't forget to go to the link below this video and download the worksheets or the PDFs for this section and try as many questions as you can. Alright guys, stay safe. Bye.